Hello everyone. Let's solve the problem palindrome linked list. So basically a palindrome is anything really that reads the same forward and backward. A notable example is an example like mom. So mom reading forward and backward is essentially the same thing. But we want to check if this linked list is a palindrome. And as you can see from the example given, 1221 is a palindrome because it reads the same backward. And we want to return false if it is not a palindrome. So if we add something like 1, 2, this is going to be false because it does not read the same backward. Backwards it reads as 2, 1, not 1, 2. Now let's give ourselves some rooms and tackle this problem. So we're going to be solving this in two different ways, the intuitive approach and using two pointers. Now the intuitive approach is this actually just came about when I thought about arrays, right? If you've tried to check if an array or a string is a palindrome, basically the best way to do it is to use something called two pointers, where we have the first pointer on the first item in the string or the array and the second pointer on the last element in the array, and then we're just comparing if they are the same thing. If it is a palindrome, the first and the last item will be the same, and as we move forward, this one will be incremented, this one will be decremented to meet at this point, and we would see that indeed this is a palindrome. But if we add something like this, right, if we add something like this, it still would be a palindrome because the first and last will be the same, and when they get to the middle, when the pointer gets to this point, they still count, they are still the same thing. But if we add something like 1, 2, right, if we add only 1, 2, and the first pointer is here, the last pointer is here, we can see immediately that this is not a palindrome, and so this is immediately going to return a false because it is not a palindrome. Now recall that a linked list is not an array, so we have to first, a linked list is basically a list, right? It's not an array. We have to traverse the entire thing to get the element at the last index. So the best way to solve this problem efficiently is to traverse the array, not array, traverse the linked list, store the values in an array. Okay, I used 1, 2, 3, 4. Let me be consistent. Store the values in an array, and then now use the two pointer thing, comparing, right, if the first element and the last element is a palindrome. So this is the intuitive approach. Now this takes a linear time operation, but we use an extra space array that is as large as the linked list, and so this is also a linear space operation. Now this is why we are actually considering a second approach, since this uses linear space, and we are basically considering that, okay, can we do this any better? And yes, we actually can. All right, this time complexity just came to me that is wrong. Not just came to me, I just realized that this is wrong. First, this is a linked list. We are traversing a linked list, and we know that this take O of n time operation, and then we are basically traversing our array, right? But we are not traversing the entire length of the array because we are moving at a speed of 2 per 1. Like in one iteration, we are considering two numbers. First, we are considering this and this, then we are considering this and this at the same time. Basically, we are dividing our step by 2. So this is going to be an O of n plus O of log n operation. So this is not a O of n operation, this is an O of n log n operation. But now we are actually going to solve it with two pointers using an O of n time complexity and a constant space complexity. Again, let's give ourselves some room and solve that. Now, this problem actually didn't come intuitively to me, but after solving it, I saw that it used a lot of knowledge that I have worked on solving linked list, and you will see that too. In fact, the card is going to be linking to the linked list playlist if you can go through those playlists and solve some of these questions that I'll be listing out. So the first thing that I want to do with this problem, okay, if we're given a linked list of 1, 2, 2 and 1, and we want to solve this using two pointer, the first thing is that we want to find the middle of the linked list. And why do we want to find the middle? We want to find the middle because if we find the middle here, right, let's say this is the middle, and we reverse the middle, so the middle linked list is going to be 2, 1. We reverse it to 1, 2. If we start to compare the original linked list up to the middle, we would see that 1, 2 is the same as 1, 2, right? But if we add something like 1, 2, 1, 2, and we found the middle here, and then we reversed this middle, so this is going to give us 2, 1, and then we still go back to this original list, right, and we start to compare the values of the middle with the values of the original list, we would see that this is not the same, and we can immediately know that this is not a palindrome. So what I'm actually saying is that let me write back our values. First, we want to find the middle of the linked list. Then we want to reverse the middle. Then we want to compare reversed with original. If it is a palindrome, they will be the same. But if it is not a palindrome, it's going to fail at this point. Now we have already solved a linked list problem about finding the middle of the linked list. It's in the cards. So if you don't know how to solve that problem, this might be a good time to just check out how to solve that problem, because we are doing the exact same thing. Then we also have solved how to reverse a linked list. Now this is reversing the middle, but that doesn't matter because it is still a linked list. We're reversing the head, and that is basically what we are going to be doing with this problem. Now just to run through it quickly again, recall that we are giving a linked list. Now when we find the middle, we are basically saying that, okay, I am at this point, this is the middle of my linked list. Fine, we've gotten this middle, great. That is our first step, get the middle of the linked list. Then we want to reverse the pointer from the head. Now we know that if we should reverse this 2, 1, we will basically have 1, 2. Finally, we want to compare. We are going to still have our original linked list, which is going to be 1, 2, 2, 1, and our reversed linked list is 1, 2. Obviously, we are going to reverse up to the length of the middle linked list, since we know that the head is going to be definitely longer than the middle, right? So once we compare up to this length and it is the same, then we can just return that it is a palindrome. We can return true. But if it is not the same, then we can return false. So this is how we are going to approach this problem, using the iterative method and using the pointers. Now this second approach uses pointers. When you are finding the middle, we are just using pointers to reference the middle linked list. When we are trying to reverse, we're also using pointers. In fact, when we walked through how to reverse a linked list, we talked about how it's just a solution of manipulating pointers, and so we are not using any extra space. We are using the pointers are already pointing to what already exists. It's a fixed state and fixed space, right? We know that, okay, you are pointing to an element in our linked list that is of fixed space. There is no extra space being used, no extra data structure, and we are also doing this in a linear time operation. All right, let's jump right into the solution. All right, so let's solve this iteratively, or not really iteratively. Let's solve this using the brute force approach. So the first thing is that we want to define the array that is going to store the value of the linked list. And while it is true, we want to append the values of the linked list. And so we are not stuck in an infinite loop. We also want to move it to the next value in the linked list. Now our left, since we want to define our pointers like we showed, one pointer, if we have something like 1, 2, 2, 1, and we already have it in an array, the first pointer should point to the first element in the array. The second pointer should point to the last element in the array. Compare if they are the same, and then move forward from there. So we can say left is 0 because it's going to represent the first item in the array, and right is going to be the last element in the array. Now we can say that while left is less than or equal to right, we want to check that they are not the same, right? Because if they are the same, then we just want to return a true. So we can just check that if left is not equal to, and recall that they are already an array, yes, so this is valid. Basically, this whole operation is valid because we already stored the values in an array. So if they are not the same, right, we want to exit with a false. Otherwise, we want to increment 1, decrement 2 till this whole operation runs, right, and then we can just go ahead and return a true and delete this. We don't need it. Let's run this, be sure that it works. This works, submit it, and we should be good to go. Cool, this works. All right, now let's solve this using the 2 pointers approach. So first we want to find the middle of this edge, and we're going to find this using a fast and slow pointer. When the slow pointer ends, the pointer they are running at the same pace, they call it tortoise and hare or Floyd cycle detection algorithm. We've used this in a number of questions, and again, if you have not solved this problem, I highly recommend that you check out the playlist attached to this video and solve middle of the linked list and reverse the linked list problem, as it will make this one so much more easier. So we are trying to find the middle of the linked list using this tortoise and hare technique. And while fast and fast.net, basically while this condition is met, then slow is going to be moving at a slow pace, right? But fast is the hare and is going to be moving 2 times faster than the slow. This condition is going to run up until this is no longer being satisfied. And we know from the problem we solved where we found our slow list, the node at the slow point, that slow is now, whenever fast ends, slow is going to be the middle of the linked list. It's going to be at the middle of the linked list. Then we want to reverse the list from the slow pointer. We want to reverse the list from the slow pointer, and when we want to reverse, we know that we are also manipulating pointers, so we need a previous node that points to what already existed previously, and in this case it is none because we have nothing stored previously. Now we are going to run this up until slow is no longer true, and then we are going to say that slow is, rather, previous is going to be slow, right? If slow is none, then we have to update that previous is now slow. Slow.next is now going to be previous, right? Because we are updating the pointer of previous, but this needs to come first. This needs to come first before previous because we are changing what previous is. So we're going to say it here that slow.next is previous, because if we change previous first, then we are losing access to the original previous, right? Also, we need to store a variable. We are also changing slow.next, right? But we need to move this loop. We need to traverse this loop by moving over to the next item. So we don't lose access to that. We need to store it in a variable. And we're just going to call this nxt, and we can move and say that slow.next is going to be nxt basically. So this is what we are doing here. In this place, we are just not slow.next. This is actually going to be slow, right? Because we are iterating it. What we are just doing here is reversing the list from the slow pointer. We are trying to manipulate the pointers where slow.next now points to previous. Whatever, if we add something like 1, 2, we are not saying that slow.next here 1 no longer points to 2, it now points to what existed previously. It's pointing to the previous node. Then previous is now slow. We now want that, okay, when the next item wants to point at a previous, it no longer points at none, it now points at this one. And then we are just updating this pointer to move on to 2. We don't, since we've already updated the next of this, we want to store the initial next in a variable so that we have access to it here. And that is basically what we are doing. Then finally we can compare, and we're going to, let's compare this using a left and right. Let's just redeclare variables. Left is going to refer to the original head of the linked list, while right is going to refer to the previous, because previous is now going to contain the new head of the reverse linked list. And let me just leave a comment here that says compare. Now we can just say that while right is true, since right is referencing the previous, I know that the previous length is definitely going to be lesser than the original head. So while right is true, if left dot value is not equal to right dot value, we want to return a false immediately. We also want to just go ahead and move on with our left pointers, and also go ahead and move on with our right pointers. Now if all of this condition is satisfied, then we can just return a true. Give ourselves some room. Try to run this. This is a bit lengthy, but I believe that once you grasp finding the middle of a linked list, reversing the list from the slow pointer, then we are literally good to go. Alright, this works fine. Thank you for watching this episode. I really hope that I said episode. Why did I say that? Oh, I have a podcast. Thank you for watching. I hope you learned something. Please give a comment if it helped you. If there's anything that you want to comment, basically, please give a like and subscribe. We are currently working through the Sean Praz Leetcode patterns, and yeah, we are trying to solve this and build our knowledge of data structures and algorithms. So if that sounds like something you might be interested in, you definitely want to be subscribed so you know when a new video comes out. Thank you so much, and I'll see you in the next problem.